This is our video for Unit 6, Day 9. So now I've gone over the parent graphs for sine, cosine, tangent. We're going to start looking at transformations. We're going to start today with just sine and cosine, and we'll get to the tangent function tomorrow. So we reviewed our transformations on general functions. Sine and cosine follow the same rules, just a couple things that are unique to the sine and cosine functions. So again, our general form for transformations, we have a sine, or it could be cosine also. They're going to follow the same rules. B to the x minus h plus k. So what's unique to sine and cosine, something new we're going to be doing, is going to be this b value here. That's going to be the frequency, which will change around the period of the function. It's not something we've done so far, but it'll be something we do only with sine and cosine. So all the other pieces of the transformation, a, h, and k, are the same as we've been working with before. So a will be the vertical stretch, or vertical shrink if it's a proper fraction or decimal. Right, with sine and cosine, what this changes on our graph is the amplitude. Changes how steep the waves are. So the amplitude for sine or cosine graph is just the absolute value of that vertical shift. So if it's negative, we don't include that. The amplitude, that's a reflection over the x-axis. We just say the amplitude is a positive of whatever that number is. So next thing is b. This is what's new, and again, this is unique to sine and cosine. This is called the frequency. So what the frequency actually tells you is the number of cycles that this function will complete in 360 degrees. So for the parent function, the frequency is 1. For every other function, when the frequency changes, that changes the period. It tells you how many complete cycles it will go through in 360 degrees. So there's a formula to relate between the frequency and the period. The period is 360 divided by the frequency. Right, or we could change this around also if you need to find the frequency and do the period. The frequency is 360 over the period. So h is going to do the same thing as it has before. It's going to be a horizontal shift, but for sine and cosine, we call this a phase shift. Right, but all that means is we're moving left and right. So same as before, if it's plus h, we're going to be moving left. If it's minus h, we're going to be moving to the right. Right, what this will change in terms of the function is this will change the starting point. So when we start working through our 5-point pattern, this will change where we start with those with that first point on the x-axis. And last one, k. Same as before, this is the vertical shift. So plus k will move up, just like with all our other parent functions, and minus k will move down. And this will change the maximum and the minimum value for the function. So it'll move the entire function up or down, so it'll move the maximum and minimum for the y values. So I'll go through a couple of examples of how this works. There's one thing with sine and cosine we have to actually write in a little bit different form in order to pull out the transformations in the way we want. So here's the first one we're going to do. We have 1/2 cosine 4x plus 180. So this doesn't quite match the form that we had on that previous slide. What we need to do is whatever is in front of the x, we're actually going to factor that out, and we're going to have um, this is going to be pulled outside parentheses, and we're going to have something else left inside here. So we're going to factor out that 4. So we're not changing the value, we're just writing in a different way that helps us work with our transformations. So if we divide 180 by 4, we have 45. So this is just a way of rewriting the function so the transformations are easier to identify. So here for listing our transformations, just like we did with our other functions, we have this 1/2 out front is a vertical shrink. If I factor 1/2, inside here we have a plus 45, means we have this called a phase shift, horizontal shift, and that's going to move left 45 degrees. All right, and then our new piece right here is that we have a frequency of 4, right, which means the period for this function, we take 360 and divide it by 4, so our period is going to be 90. So this is how we'll go ahead and start dividing up this graph. So here, since we're going left 45, we're actually going to have to extend our graph backwards a little bit and start our cosine pattern at negative 45. Right, the full period would be 90, so to get to 90 we have to go out to a positive 45. Right, then each point will occur every 1/4 of the way along through the period, so if we take 90 and divide it by 4, that'll help us mark out our other points. 0 is going to be 1 point, and then we're going to move 22 and a half to finish off our pattern. So we see the vertical shrink is 1/2, means that maximum will go up to 1/2 instead of all the way up to 1, and down to negative 1/2 instead of down to negative 1. So once we've marked off our graph all this way, there's no vertical shift on this one, so we don't have to move it up or down. Once we mark this off on our graph, the last thing we do is just have to mark out the 5-point pattern for cosine. So cosine starts at a maximum, so go to negative 45, mark off a maximum, then 0, minimum, 0, and maximum. Right, and that will give us our cosine wave. Right, and then we can go through and look at all our different properties for this function. Now we have the graph. Right, the domain we know doesn't change. Domain is still going to be all real numbers, negative infinity to infinity. The range does change. The range will change with the vertical stretch or vertical shrink. Also with the vertical shift, will change the range. So here, it only goes down now to negative 1/2 and up to positive 1/2. And we use brackets here to include those values on either end of the range. Then we know our frequency is 4. Our period for this function is 90 degrees. And then the last property we'll look at is the amplitude is 1/2. So go through a couple more examples like this and show you one using radians also, because that's the ones you'll be working with in class tomorrow. We'll use radians instead of degrees. So same idea. This one is a sine function. We have a couple new things. We have reflection thrown in at the front of the function and a vertical shift. So that's going to be a couple new things for this one. So yeah, we're going to start just by listing all the transformations. So Negative out front is going to be reflection over the x-axis. At the end, we're going to have a vertical shift up 5. For the phase shift, we're going to rewrite this part right here. So rewrite this as negative sign, and we're going to factor off that 2 in front of the x. So it'll be x minus 2 now, plus 5. So now we can tell our phase shift is going to be right 2, and then our frequency is going to be 2, which means the period will be 180. So again, once we have all this, we can go ahead and start graphing. So first thing is moving up 5, so that's going to change the midline of the function. Right, so all those in the 5-point pattern, all the points that are 0 are going to be on this line instead of on the x-axis. The amplitude, there's no change in the amplitude, there's only reflection, so we're still going to go up 1 from that 5 and down 1 from that 5. And the last thing to mark off will be all the points on the x-axis. So since we have a phase shift to the right by 2, that means we're starting at 2. Period's 180 means we're going out to 182. Then everything else happens every 1/4 of the way through that cycle. So that would be 47, so it's 45 would be the period divided by 4. 92, 137, and then 182. Right, so it's a jump of 45 in between all of those, so it's even 1/4 of the way through the period. So once we mark off all of that, we're going to use our pattern for sine. The only difference, because the reflection is instead of going up to its maximum first, it's going to go down to its minimum first. We still start at a 0. Because of the reflection, we go down to minimum, back up to 0, up to maximum, and then back down to 0. Again, we can look at all the different features of the function. So domain isn't changing, that's going to be all real numbers. The range, because the vertical shift is going to change now, it'll be between 4 and 6. Period for the function is 180, and that goes along with the frequency of 2. Our midline, and the midline will be the same as the vertical shift. Is the line y equals 5. That's the new midline since we shifted the whole function up. Alright, so one more example where we're going to graph. And on this one, we're going to be using radians. Right, so everything we're going to go through is going to be the same as we did for the last 2 examples. So first, right, because of all this, we're going to want to rewrite the function. So we're going to factor that 2 out. And rewrite the function so we can see what the phase shift actually is. Once we do that, it's the same as before, we just list all our transformations. So 4 out front is a vertical stretch. Right, we know the 2 inside here is the frequency. Right, and if 2 is the frequency, that makes our period now 180 degrees, or this one's using radians, so that's the same as pi radians. And then here our phase shift, we're going to be moving right by pi over 3 radians. So we're going to go through everything the same. The only thing that will change with the radians is going to be the marks we put on the x-axis are going to change. So we start, we see there's no vertical shift up or down. So the midline is going to stay along the x-axis. The amplitude is 4, so we're going to be going up to 4 and down to -4 from the vertical stretch. We know our starting point on the x-axis will be the phase shift, so we're going to be starting at pi over 3 as we count out our pattern. The full period of the function is pi radians, so we have to add pi to pi over 3, which would be the same as 4 pi over 3. Right, so we have pi over 3, and we're going to add pi over 1. We need a common denominator. That'd be 3 pi over 3, and that's where that number comes from. Right, every other mark is going to be exactly 1/4 of the way through the period. So again, the period is pi radians, so each jump should be pi over 4, 1/4 of the way through the period. So we're going to be starting at pi over 3, and we're going to be adding pi over 4 to get to the next step. So again, we're going to have to use a common denominator. So I'll have 4 pi over 12 plus 3 pi over 12. So our next jump we're going to go to will be 7 pi over 12. Right, then we're going to do the same thing. We're going to take the 7 pi over 12, and we're going to add another pi over 4, or 3 pi over 12, which gives us 10 pi over 12. If you want to leave it like that, that's fine, but you also write this as 5 pi over 6. And then we'll take that 5 pi over 6, or 10 pi over 12, and add one more pi over 4 to it. So that's again 3 pi over 12, so we get 13 pi over 12. Again, you can check it each step along the way. We're moving up by exactly the same amount. Now we've marked off everything. We marked off our max and min on the y-axis. We marked off every quarter point along the way on the x-axis. Now we just count out the pattern for sine. So that starts at 0, max, 0, min, and 0. Right, so there's our graph for this function. So everything with radians, you go through the same way. The only difference will be cutting up those pieces on the x-axis is going to be a little trickier because there's going to be more fractions involved. If it helps you, you can work in degrees first and then work back to radians if you find that easier. So last thing we're going to do is without graphing, how we can look at the rule for a sine or cosine function and find information like the max and minimum or domain, range, amplitude, any of that stuff without actually going to the graph. So in this example, we have a cosine function. A very common question you see pop up on a lot of tests and on the final exams is asking for the max and minimum values for a function with transformations on it. So the way this works is we know that a cosine from the parent function, we know the largest value for cosine is 1, and the smallest value that cosine can ever be is negative 1. So we do to find the maximum minimums, we replace the cosine piece with 1 and negative 1, because no matter what we put in for x, the biggest we can ever get this cosine term to be is 1, and the smallest we can ever get it to be is negative 1. So first replace it with 1. So that'd be negative 3 plus 6, and that would be 3. So that's going to be either my maximum or minimum, and that's going to be 1 bound from my range. I'll do the same thing replacing it with negative 1. Now from that rule, I already know that the maximum for the function will be 9, the minimum for the function will be 3. All right, without having to graph it, I can find out that much. And there's also some other things we know from that. Obviously, the range will go between those two values from 3 up to 9. To find the amplitude for the function, right, obviously we can just take the absolute value for the vertical shift. We can also find the amplitude by taking the distance between the maximum and minimum, so maximum minus the minimum, and dividing that by 2. So here that would be 9 minus 3, which is 6, divided by 2, and we get 3. Similar formula for the midline. Instead of the half the difference between the two, it's half the sum, or the average of the maximum and the minimum. So here that'd be 9 plus 3 divided 2, that's 12 divided 2, or 6 would be our midline. So that would be our vertical shift, and again, you can see that from the function rule. So here's just a couple of ways you can actually pull off all these pieces of the function without actually graphing it. If you got this on a test or on your final exam, you wouldn't have to actually go through and graph this whole function by hand. You can just look at the pieces of the function to determine different properties and how the transformations have changed. So that's it for this video. Again, if you want to see some more examples or a different video, there are a lot of videos on YouTube. Just search for transformations on sine or cosine.